Hello everybody, can you hear me well? Alright, I'm Nick and today's presentation is a piece of art, so please sit back on your chairs because we start. First, I would like to understand more about the people in this room. How many of you guys are software engineers? Alright, how many blockchain developers? Alright, cool. Are there any non-technical guys at all? All right, thank you. Okay, a couple of words about the lecturer. I'm a software engineer having interests in different fields, and I'm a happy father of an amazing small daughter. And in my friends' circles, I'm also known as a hardworking homo, which is also true. Anyway, we're not here to talk about me. I'm not important. What is important is what I know and what I want to share with you guys today. Today we're going to talk about blockchain, data storage, and we're going to look at the different options for that. Blockchain is a database, IPFS, distributed file storages, NoSQL databases, and two interesting projects, BigChainDB and TiceDB. Заповядайте. As bigger the bubble is on the screen, as more we stay and more we talk. We have to think of blockchain as we think of time. What is done, and we cannot get back and change the facts. Let me clear one of the most wrong understanding from the business of blockchain. Blockchain is not a replacement for distributed database. 2017 was the year of the blockchain. A lot of amazing projects appeared over the horizon. We now talk about the next phase of internet. We're talking about the decentralized World Wide Web, but we all are aware that there are still a lot of problems that we have to find solutions for. And one of these problems is the data storage. How we currently store big data in the blockchain? We don't, because we must not to. Why? Because it's expensive. On the screen you can see the simple calculations, how much it's going to cost. If you want to store 1 gigabyte of data on the blockchain, that's going to cost 32,000 Ethereums. If I now open the CoinMarketCap and see the price of Ethereum, I'm going to see that in order to store 1 gigabyte of data on the blockchain, I have to pay something like $17 million US for 1 gigabyte of data. Really? Anyway, if we even decide to spend this crazy money for storing data in the blockchain, we're going to face with the next problem. The size. The current size of the Ethereum blockchain is something like 70 or 80-ish gigabytes for full node. If we start putting big data, the size of the blockchain will increase rapidly, and soon it will exceed the publicly available hard drive capacity. Then a full node will require a specialized hardware which will result in dangerous centralization of the blockchain. And we don't want this to happen. What else? The speed. We know that transactions are slow to execute, so it simply does not work for feature-rich applications. What else? Immutability. We know that the immutability is the biggest strength of the blockchain itself, but from a database perspective, we know that it's a big weakness. It's a big weakness. We know that the CRUD operations, I'm talking about create, read, update, and delete, they are not supposed to be used in the blockchain by design or by nature. All right. I would like you to remember that storing big data in blockchain is not even an option. What are the options then? We can use peer-to-peer file systems as IPFS, decentralized cloud file storages like SIA, like Storage, like Ethereum Swarm, and more. We can use distributed databases as Apache Cassandra, as RedThingDB, MongoDB, and many others. And these are the two interesting projects, BigChainDB, which is a blockchain, and TiceDB. All right, let's dig deeper and put some dirt under the nails. IPFS stands for Interplanetary File System, and it's a real peer-to-peer file system. The technology behind IPFS is based on the BitTorrent protocol and a distributed hash table. How it works: once uploaded, each file has been given a cryptographic hash. This is its unique identifier over the network. By design, duplications are possible, so IPFS takes care of all the duplications and removes them if there is such need. Each node stores only the content that it's interested in, and of course some indexing to help figure out who is storing what in the network. Looking up the files is the process of asking the network to find the node storing the content behind the unique hash. Each file can be found by human readable names using the centralized naming system called IPNS. IPNS is a feature of IPFS, and I would like to raise a note here. We can have a search by human readable titles of the files, but we don't have a meaningful content search in IPFS. There are some good moments here. The first one is that it's a real peer-to-peer file system, so if you want to share your files, you have to upload them first on your computer, and then anybody can download them if they get interested in your content. The next thing that is it's content addressable, which means that there is no way to search content by given address. All right. Of course, there are some drawbacks here. The first thing is that if you want to share your files, you have to stay online. The next thing is that it serves static content only, which means that once uploaded, a file cannot be modified. And of course, there is no meaningful content search. All right, it's a time for a quick demo. So if you want to run, if you want to set up and run IPFS node locally, you just have to go to the official site of the IPFS and follow the installation guide. I just want to tell you that it's not straightforward, but it's relatively easy, and you're going to be fine. Right after you install the IPFS on your machine, you can go on the command prompt and just run IPFS daemon. This will start your local node. I already did that just before the session, and I now have some errors here that we can just ignore at this moment. When you have your IPFS node running locally, you can access the web user interface from your browser. As you can see, I'm on the localhost. Here you can see the connections, all the peers that you're connected to. Also, you can see the files that you have uploaded in the IPFS. There are also a couple of other options like DAG and configuration that there is no need for us to cover in this session. All right, once we have the IPFS up and running locally, we need the bridge between our ASP.NET application and this IPFS node. So we need a NuGet package. Simple enough. Here is my solution. And if I go to Manage NuGet Packages, hitting the installed packages and searching for the IPFS, I can show you that I just installed just two packages, IPFS.API and IPFS Core. And that's enough. All right, let me show you how it works. Here is a DApp, decentralized application, called My Ethereum Book. This project is not in production because it's not ready yet, but there is a smart contract behind, which is uploaded in the Ethereum Ropsten test network. The whole idea about behind the My Ed Book is that unlocked users can store most used and most important and frequently used Ethereum addresses on the blockchain. In this project, I'm using the IPFS to store the avatars of the users. It's a simple project, but it's good enough for the purposes of our session. If I open the image in new tab right now, I'm going to see that the image is uploaded, is stored actually in the IPFS. If I now choose another image, for example this one, and upload it, and open the new image in new tab, I'm going to see that this image is already in the IPFS, and that was very, very fast. Also, if I copy the hash, the unique hash, and search for that hash in the files in my IPFS instance, I can see that it's here. All right, what's the code behind? So here is the index action method of my managed controller in the backend, and here's a place where I upload the avatar. And here are the simple 5 steps that I follow in order to upload the file into the IPFS. The first thing is that I save the file in the local file system. The next thing is to get an IPFS instance. The third point is to add the file to the IPFS, and it's just happening with single line of code. Add file sync, passing the path of the file. The fourth thing is to obtain the unique hash that has been given to the avatar. And the fifth step is just to update the user. That's it. Simple enough. Any questions? Yes, please.
English.
No problem.
Is it mandatory the path to be like a full path on the machine and not a virtual one or something?
Yeah, it could be virtual one or relative one. Doesn't matter. Yeah. All right. I'd like to say a couple of more words here. I'm going to open the project in the GitHub, and I'm going to say a couple of words about the architecture and the different options. So in this D app, I'm using ASP.NET MVC. In the front end, I'm using Web3.js and MetaMask for communicating with the smart contract that is uploaded on the Infura Ropsten test network, actually. And I'm using the Ethereum. It's a .NET client for accessing the smart contract. Okay, you can see that in the backend there is just one. It's just one way. The relation is just one direction. But from the front end, it's 2 directions. Does anybody know why is that? Anybody of the blockchain developers? All right. The reason is because it's not a good practice to play with user's private key on the back end. We all know that all servers are under attack 24/7, and it's just a matter of time the server to get hacked. So when you're developing decentralized application, you have to leave the user to take care of his private keys. That's why we're using MetaMask, and that's why only through the MetaMask we're writing to the smart contract, and from the backend we're just reading the data, but not writing. All right, let's get back to the IPFS. The first option and the flow that we have here is the file is uploaded on the front end, then it's received from the backend. From the backend, it's pushed to the IPFS. IPFS returns a unique identifier, which is the hash. And after that, we keep the hash in the SQL server. This is the first option. What is the second option? The file has been uploaded from the front end and received from the back end, pushed to the IPFS, and the IPFS returns the unique identifier. Instead of saving the hash in the SQL server, we can save it on the Ethereum contract. This is only in case we think and we consider that this image or this file is important and we want to store it on the blockchain. If it's not important, we can store it in the SQL server. Any questions here? All right.
How can we save Ethereum when we don't have private key? Is our private key of the application? Or?
That's great. There are several options about that. Actually, there are some libraries that we can use for interacting between our backend and. Sorry, I just want to open that between our backend and where was my GitHub? Yeah, here it is. If I have to be honest, I'm not exactly sure, and I just know that there are ways we can write data to the Ethereum contract, and we can take care of the user's private key. For example, all the online markets that we know, and I'm talking about Bittrex, I'm talking about Binance and the other, they're doing exactly this. They're working, they're using the user's private keys and public keys, and they write to the smart contract. I have never developed that before, so I cannot go deeper into details, but there is an option, so we can do that. So sorry if sorry that I cannot answer the question exactly, but it was a good question. All right, let's continue.
In most cases, user pays the bills.
Exactly. Yeah. Exactly. Yeah. And the bills are not small. I mean, one transaction is like starting from 40 cents for US dollar cents. So yeah, they're not cheap. Anyway, there are decentralized cloud file storages that lift some of the limitations of the IPFS. From a user's point of view, decentralized cloud file storages are nothing different than the standard cloud file storages. I'm talking about Dropbox, for example. But the difference is that the data is stored on the user's computers that are who are renting their hard drive space, who are offering their hard drive space for rent, instead of data being stored in the data centers. There are plenty of good projects nowadays. For example, we have SIA, we have Ethereum Swarm, we have Storage, and some more. They are very good actually. They are fast enough, and they have enormous capacity. All right, let's take a look on the roadmap of SIA, for example. And there are a couple of words that I would like to share with you. So SIA has been founded in 2014. Then they released their beta in 2015 and going in production in 2016. What is their final goal? Is SIA to become a true competitor to Amazon S3 and companies start to switch to SIA as an alternative. And I pretty much believe them, because SIA has proven over the years, and I really believe that there is a good potential in that coin. So if there are any miners in the room, it's a still good coin to mine. Of course, that's not a financial advice, because nobody knows what's going to happen. What else? The storage. Let's see the storage website. Here I wanted to show that the price for 1 gigabyte per month is less than 2 cents compared to $17 million. Yeah, it's ridiculous. Also, there is a very good feedback from very important persons in the field. So I think that this project have a lot of potential. Anyway, there are a couple of drawbacks here too. The first one is that they serve only static content, which means that once uploaded, the file cannot be modified. And of course, because they are stored on, they are hosted on the rented hardware, they are not free. But anyway, they lift the IPFS problem that you have to stay online in order to share your files. With distributed cloud file storages, you don't have to stay online in order to share your files anymore. Distributed databases. Let's take a look of distributed NoSQL databases. Why NoSQL databases? Because strict transactional databases cannot be truly distributed because of the restrictions of the CAP theorem. In the context of database, CAP theorem says that in order to make a database distributed, you have to choose, or actually you have to sacrifice either availability or consistency. NoSQL databases choose availability over the consistency and replace it with the so-called eventual consistency, where all the nodes in the cluster will become consistent and sometime later. There are a lot of good projects, a lot of such projects nowadays. I'm talking about Apache Cassandra, RethinkDB, MongoDB, I already mentioned them. They are very good too. They are very fast, they are fault tolerant, they are scalable, and they support and they support rich query language. But they still have one big drawback for our blockchain application. Can anybody say what's that drawback? All right. They're not Byzantine proof. Of course, I'm not going to jump into the details about the Byzantine general's problem. As a software engineers, all we have to know is that if we're if we are developing a blockchain project, and if we choose a NoSQL databases for big data storage for our application, we're in a big trouble. Because all the nodes in the cluster fully trust each other. If there is only one malicious node in the cluster, it's going to destroy the entire database. That is the Byzantine general's problem at all. All right, a couple of words about a big chain DB and ties DB. The team behind Big Chain DB claims that they're gonna solve the problems with the data storage and with the transaction speed. Actually, Big Chain DB is a blockchain with very fast transactions and enormous capacity. How is that possible? It is built upon RethinkDB cluster. RethinkDB is NoSQL database. And Big Chain DB uses the RethinkDB cluster to store all the transactions and the blocks. All the nodes have full write access to the cluster. And here comes the problem. If there is one malicious node, it's going to destroy the entire database, the entire RethinkDB cluster. So it's not Byzantine proof. Anyway, the team behind are aware of that problem, and they promise that they're gonna fix it some point later, if even possible. Anyway, Big Chain DB is probably not a good option for public database, for public blockchain, but might be a good option for private blockchain. What's the difference between public and private blockchains? Everybody can participate in the public blockchain. Everybody. Example for public blockchain is a Bitcoin. In order to participate in private blockchain, you have to receive an invitation first. And this invitation will be validated from the starter node and from predefined set of rules. Example of private blockchain is Hyperledger Fabric. It's a great project. Anyway, a couple of words about TiesDB. TiesDB is the world's first decentralized public smart database. Is it? Is it the answer to the D-app storage? TiesDB is a deep modification of the Apache Cassandra database. So it has all the features that a NoSQL database has, but adds Byzantine fault tolerance. With these features, TiesDB can become a public blockchain database that will enable feature-rich applications on Ethereum and other blockchains with smart contracts. These are the features that they promise they will support. You can see that they have almost 5 force for distributions, publicity, resistant to Byzantine general's problem, sharding support, speed, ability to store structured data, ability to delete data, and request language with an ability to conduct search using more than the primary key. How it works? The database is writable by any user. The users are identified by their public key, and all the requests are signed. Once created, record remembers its creator, who becomes an owner of the record. After that, the record can be modified only by the owner. Everyone can read all the records because the database is public. All the permissions are checked on request and replication. Additional permissions can be managed via a smart contract. And here is the most interesting part. The team says that they will launch this in Q4 this year. Promises. There are some good ideas appeared over the horizon, but now they are just promises. They are just ideas. I'm talking about the other 1,500 projects that we see in the coin market cap today. So, nowadays, if you're about to create a blockchain solution, you will probably choose IPFS just because it's the best option at the moment. Encrypt the data with the user's keys, upload it to IPFS, and store the hash on the blockchain, just the hash on the blockchain, and the big data off the blockchain. This is how we store big data in blockchain projects today. Remember, storing big data in blockchain is not even an option. Keep your blockchain as minimal as possible. And as far as I can see, you got no more questions. I would like to say thank you. You all were great auditory. Thank you. Of course, that was a joke with the questions. So if you guys want, just shoot me. Any questions? Anybody? Yes.
You mentioned IPNS, the name service that's searching for the hashes.
Right.
What about if you have millions of files and a lot of visitors are accessing this web interface and requesting search in this name service?
Yeah, that's interesting. Interesting. Unfortunately, I'm not experienced with that, so I can't say what's going to happen.
Can I run like a local private only for the company name server for this IPNS?
Absolutely, yeah, absolutely. And actually, there is one very good business idea that crossed my mind over developing the session today. There is nowhere IPFS as a service, so this could be a really great project if somebody offers IPFS as a service, because this will have a lot of. I mean, it's a good idea and will be used a lot, because the blockchain development is getting more and more famous, and the usage is really big. So IPFS is something that will be used in future a lot, for sure. Yes?
Yeah, first thank you for the lecture.
Thank you.
Does IPNS support some kind of versioning? So for example, as far as I understand, it's not possible to delete files and update them.
Right.
You can put the same name, because effectively it is the same file, but probably updated.
Right.
And let's say your application wants to take to find the file by name, not by hash,
Right.
and to use the latest version of this file.
Right.
So is it possible to somehow search for file names but take the latest version if it's not possible to change the files?
I'm not sure. I'm sorry. I'm not experienced with the IPNS at all. I just know that there is such feature, but didn't have the chance to test it. Yeah, to play with it. So I don't know the answer again.
Okay.
Thank you. All right. In case there are no more questions, I would like to say thank you again. And excuse me for didn't answering all the questions, but I would love to make another session and answer all of your questions. It just was my first time. Thank you very much.